Hi there, thanks for checking out this video. What we want to show you in this video is some of the basic techniques we use for solving differential equations. And we're going to talk in just a couple of days more about this particular idea. But we want to try and get you familiar with the notion of, instead of actually just trying to picture it with like a slope field, actually solving it by hand. The basic idea is what's known as separation of variables. And the idea is to take a differential equation written like this one, for example, to get it into the form where you have some function of x dx on one side and some other function of y dy on the other. In other words, what I'll say when I'm teaching this is simply get your x's and y's separated. Find a way to get nothing but x's on one side and nothing but y's on the other. And you can actually split this differential, this dy dx, in a way that creates it like this. You can kind of treat it like it's a fraction. It's mathematically not exactly correct, but the same concept works. Okay. But then the idea, once you've got that separation, is to integrate both sides. Okay. And then try to solve for y. So we're going to do some very basic work with this, and we'll work on this more specifically. The next learning target actually asks you to work on this for more specific and maybe more complicated differential equations. But this one's actually pretty easy to work with. If dy dx equals 4 minus x, by the way, you actually could probably solve this one in a pretty straightforward way, because the entire right side is just a function of x. So actually simple integration would work here, but in the vein of trying to show you the technique here, I could multiply both sides by dx. And if I did, I would have dy on the right side, and I would have 4 minus x times dx. And in mathematics, we're usually a little sloppy with this notation. We technically should write that, but we usually don't. But actually, I've accomplished it. I've separated my variables. I've got nothing but y's on the left side. Nothing but y's here, and nothing but x's on this side. We should be able to integrate. So that's exactly what I'm going to do. I'm going to integrate the left side, integrate the right side. This can be difficult here because there's a sneaky function of y here, 1. This is 1 dy. And the antiderivative of 1 would just be whatever the variable of integration is. This is y. Okay? The integral of dy is y. And I can integrate this function as well. 4 minus x dx, I need a function whose derivative would be 4 minus x. And I think 4x minus x squared over 2 plus some constant will get the job done here. And, this one's already solved for y, so I don't really have any more work to do. I think that function is the solution to this differential equation. That is the equation whose expression for dy dx is 4 minus x. We're going to work a slightly different one here, and even though this one looks very similar, it actually works out significantly differently. Okay. We want to solve the differential equation dy dx equals 4 minus y. So it actually often sometimes helps to think of this almost like a proportion, where you could use that cross multiplication property or that cross product property in a lot of different ways. You could say that dy times 1, which is just dy, equals 4 minus y times dx. And I want you to reject the notion to distribute that dx here. That's really not very helpful, because if I did, I would get a term that has blended x's and y's, and that's not really what I'm looking for. The best thing to do now to get x's and y's separated would be to divide both sides by 4 minus y. And actually what I have is 1 over 4 minus y times dy. That's the left side. And on the right side, my 4 minus y's cancel, and I just get dx. And I've accomplished it. I've separated my variables. I have nothing but y's on the left side, nothing but x's on the right side. So what am I going to do? I'm going to integrate both sides. Now the right side is a little easier to me to integrate because it's just the integral of dx, and that's x. And we need some constant, and I usually put the constant on the right side. You don't need to list both of the constants of integration because if you added them together, you would get one constant. But I need to think about how I would integrate this, 1 over 4 minus y dy. And I think I remember a formula for integrating 1 over stuff. It was ln of stuff. So if I do a quick substitution, if u is 4 minus y, du would be negative dy. And I would need it to just be dy. So my substitution would be negative du equals dy. So this integral right here, would become negative the integral of 1 over u du, which is negative ln of the absolute value of u. And by the way, I shouldn't write u. I should write 4 minus y. Okay. Now, the step I do need to pull here is that I need to solve that for y. So I want to think about how I would do that. One of the best things I might consider doing is dividing both sides by the negative here. We're changing the sign of both sides. So ln of 4 minus y's absolute value is equal to negative x, and I'm still going to write plus c. The reason I'm going to write plus c is that if I were to change this to negative c, it's still some arbitrary constant, so I may as well just make it plus some new constant c. The trick here to get y separated is to think about taking e to both sides. So if I make e the base of each side, legal move, e to the ln of stuff is just the stuff. I'm going to get a little sloppy here and drop my absolute value for reasons we can talk about later on. Probably when we do this in the next learning target. And at this point, what I need to do is just solve for y. So I could subtract 4 from each side. Negative y is e to the negative x plus some constant, minus 4. And if I divide both sides by negative 1, I'll get y equals. You know, one way to change the sign of each term is to reverse their order if there's a subtraction sign there. We could call that 4 minus e to the negative x plus c. Now I want to, maybe this is a point where I won't show you this trick either, but there's something else that we can do with this, and I'll cover that more in the next learning target. But essentially, the back of the book answer might look a little bit different than what you see here. Let's try one more, and actually I think this one works out a little bit better. We've got y prime equals square root of x over 3y. And it's worth pointing out that I can write y prime as dy dx, and in this particular case it probably benefits me to do so because I'm looking to truly get my x and y parts separated. And I think I can do it with just simple cross product property of proportions now, because if I take 3y times dy, that should equal, by that property, the square root of x times dx. So, you know, it actually turns out that solving a differential equation where y prime is set equal to something in x's over something in y's actually works out pretty nicely. So I've accomplished my separation of variables. I've got y's on one side and x's on the other. Let me integrate. So if I integrate 3y, I need a function whose derivative is 3y. How about 3y squared over 2? And if I integrate square root of x, you know, that would be like x to the 1/2 power. And the rule for integration of a power said add 1 to that power and divide by that new number. So that would be like x to the 3/2 divided by 3/2, which would be the same as 2/3. Now I want to solve this for y. So I think a really smart move would be to multiply both sides by 2/3, because the 2's and the 3's would all cancel, and I'm just going to get y squared on the right side. But if I do it to the left side, better do it to the right side as well. So y squared would be now 4x to the 3/2 power divided by 9. And again here, oh, and by the way, I realize I left off my constant of integration, plus some constant c. And now I need to take the square root of both sides. So I've got y equals, and listen, I know this is 2 terms, okay? So I can't really do the square root of each term. I just need to write what was there and do its square root. Okay. So 4x to the 3/2 power divided by 9 plus c, I need its square root. And the other thing I should think about here is that, remember that when you solve an equation like this in algebra class, like a squared equals 25, remember that when you took a square root to solve, you could have both options, positive or negative. Well, my answer here should probably reflect that too. This part's going to take some practice, so this is a good time for you to try a few. Thanks for watching.